Good evening, everyone. Good evening to what I'm delighted to say is a full room here in London. I can't remember the last time I saw a full room at one of these events. So it's nice to see life getting back to normal somewhat, or maybe it's just the level of interest in this particular lecture. And we had, last time I checked, before I stood up, in excess of 60 participants online as well. So, and I'm sure that number will rise as Andy starts. So, my name is Noel Travers. I'm the chair of the Railway Division of the Institution of Mechanical Engineers, and I'm absolutely delighted to be hosting this event, or we are delighted at the institution to be hosting this event on behalf of the Railway Engineers Forum. Some admin, first of all. If there is no fire test tonight, if there is an alarm goes off, the alarm is a continuous bell. Please make your way to any of the illuminated fire exits. Without delay, leave the building by the main front doors, turn left along the pavement without crossing the road, pass beyond the end of the building and wait on the wide pavement for further instructions. Fire stewards will be on hand to manage the evacuation. Do not re-enter the building until the senior fire steward or fire service give permission. There are no fire drills due to take place. Therefore, should the alarm sound, please evacuate. So as I say, I'm delighted to host this event on behalf of the Railway Engineers Forum, and the Institution of Mechanical Engineers are delighted to host on behalf of the Railway Engineers Forum. The aim of the Railway Engineers Forum is to harmonise various strengths of the constituent institutions in devising and implementing each of the institution's programmes of activities in support of the railway community. Where realistic and appropriate, it is the aim to provide a common voice on railway topics and coordinated response to requests for professional comment in the railway field. The specific aims and objectives of the Railway Engineers Forum are to bring together the particular skills and strengths of participating institutions, to facilitate a coordinated and unified yet independent non-political source of expertise in the field of railway engineering and operations, and to provide and publicise a coordinated programme of events and joint ventures. If anybody wants to know more about the Railway Engineers Forum, then we have some representatives here tonight, so please do ask. So it gives me great pleasure to introduce Andy Doherty. And yes, people did check whether or not I could say Doherty properly, but as an Irishman, it's probably one of the few names that I can pronounce very well. So excuse me whilst I read out the details of Andy's biography, which is long for good reason. He had a very distinguished and successful career. So allow me to read it through. Andy is the Chief Technology Officer for GCRE, the Global Centre for Rail Excellence. Andy's role is to provide the vision and leadership to the technology strategy and development of the UK's first genuine full-scale railway innovation facility. Designed to provide a net zero energy system to run a rapid and 100% realistic endurance testing of infrastructure, train and whole system integration testing, validation and certification. Andy has set out the GCRE strategy to build its own digital twin of the facility, a BIM construction enabling automated operations, hard in the loop testing. Andy is a fellow of the Royal Academy of Engineers, and he's wearing the tie. He is an electrical systems engineer with expertise in the railway system, rolling stock design, the mechanical interface between the train and track, transmission-based signalling systems such as ETCS, and electromagnetic compatibility. Andy was previously CTO of Network Rail. He provided the vision and leadership to its technology strategy, its research and development programs, and leading engineering interaction with the UK railway industry and within the European railway sphere. During his role as CTO, Andy was the chair of the Technology Leadership Group, which leads the R&D and innovation strategy for the whole railway. This group provides guidance on the vision for the future technology of the UK railway. He was chair of the VT SIC, the Vehicle Track Systems Interface Committee, and the Train Protection Steering Group panel. Andy was chair of Network Rail Acceptance Panel for 9 years. Andy continues to work for the European Commission as an advisor to the ERJU. He has set out the strategy for the development of the future European railway system architecture, and Andy has represented the UK railway over the last 20 years extensively within the European railway regulatory, standards and research processes as chair of the EIM Technical Strategy Group and lead of the group of representative bodies work for development of interoperability and TSIs in Brussels. Andy was also Network Rail's representative on the Shift to Rail governing body and was chair of the European Rail Research Advisory Group for 5 years. Andy held several senior roles in London Underground over 22 years. He developed the technology for deep-level tube one-person operation and managed the introduction of one-person operation over most of the Underground in 1987. He went on to engineer and then manage the Central Line upgrade, including new trains, ATP, and continuous ATO powered infrastructure, and also led the Northern Line new train and line upgrade programme. Andy's here to talk about the Global Centre of Rail Excellence, which I believe is one of the most interesting, creative, and crucially important additions to the rail infrastructure landscape for many years. And as the previous managing director of one of the major UK train manufacturers, the absence of such a testing facility has been a blight on our industry for quite some time. If we can, as an industry, collectively help it become a reality, then there is no doubt that it will transform the innovation landscape in the UK and Europe, bringing products to market faster, supporting our path to net zero, and helping to lower the costs of rail. And we will be all the better for that. Andy is perhaps too modest to admit it, but he is one of the fathers of the GCRE vision. I think, as we all know, Andy has been quietly thinking, planning, and designing the layout of GCRE on various scraps of paper for many years now. And we should all be grateful for the tenacity, leadership, and sheer bloody mindedness that has helped to get to the point that in 2025, when it opens, our industry might just get the world-class testing, certification, and innovation facility we have lacked for so long. And that is why I'm so delighted to have Andy give his lecture here tonight and share his thoughts with us. So without further ado, I'll introduce Andy, and I'm delighted to say he's turning his microphone on. Hopefully it's working. Green light. Flashing. Can people hear? Can people online hear? Let me just check.
Oh yeah, no, it's working now.
You're on.
Yeah. Thank you. I thought I was going to give you a £5 for that introduction, but I'll have to give you a £10 now. Or that, or I'll escape out the back beforehand. So thank you, Noel, for the introduction. We're going to take you, I'm going to take you through a little journey that we're trying to do with the GCRE, the Global Centre of Rail Excellence. I've called it Thinking Differently because we're trying, after many, many years of trying to do this, I think we're actually going to succeed with this and build this. But we've had to think differently. We've had to create a new proposition for it. So hopefully these slides will take you through that journey with us. So I'm going to take you through background to testing and innovation. Actually, probably a story that we all know too well. I'm going to go through then the introduction to the GCRE, where is it, what is it, etc. Then we're going to talk about the capability and doing the innovation, doing the engineering differently. And as this is an IMechE Railway Engineering Forum lecture, I'll spend some time on the engineering, which we generally skip over when we're doing other presentations like this. But we engineers should share these things with us. You know, we're allowed to talk amongst friends. You know, as soon as somebody else comes in the room, we're in trouble. But let's talk about those things and then talk about skills, knowledge, innovation, how we're going to do all those things, how we're going to make the net zero jump, and then other opportunities as well. So there's a long story in this. So, and many of you will know this, we've all had various testing facilities. I mean, BRB had Old Dalby that it played around with for a while. Technically, Old Dalby now turned into RIDC Riddick, but it's a up and down railway. You can't really do much mileage on it. And actually, technically, it's not a railway, it's an industrial site with very strictured planning access issues. We've played with various mechanical facilities, laboratories, etc. We had one at Ealing many years ago, didn't we? We played crush components. At least I managed to crush a few components in it. But we've never really had a properly designed, full-scale facility that we can actually have as our toy train set that we can play with as engineers. And certainly after Hatfield accident 2000, I was asked to sort of solve this problem called rolling contact fatigue. And one of the things I wanted to do was learn more about rolling contact fatigue, and talking to Railtrack then and Network Rail later, saying, and I want to grow more cracks in the rails, really didn't go well with that logic, did it? So I went to Pueblo in Colorado, where I could grow cracks safely in a controlled environment. Cost a fortune. It did actually produce a result. We actually have a very good rail crack management policy in the UK now, and process from it. But we couldn't there were so many things we could not do on the mainline railway because of the stricture. You know, we're running passengers. It's not about testing passengers. We shouldn't be exposing passengers to that process. But we need a place where we can do that. You've only got to look at, if any of you was on LinkedIn just a few weeks ago, Rolls-Royce were testing a new Trent engine, had a carbon fibre containment for the fan blades and everything. They blew it up. They spent £30 million on the engine, blew it up. They took it to destruction, and that's what they wanted to do. They wanted to take it through the whole cycle and actually understand its failure modes and everything else with it. It's what lots of industries do. We don't do too much of that sort of thing. Occasionally we do, but not often. Actually, this problem of infrastructure testing and whole railway system testing is not just confined to the UK as a problem. Europe hasn't got that as well. If you look at Velim, if you look at Wildenrath, they can test trains, but they don't test infrastructure. They don't test the system. It tends to represent a brand new railway, whereas actually what we want to represent is the real railway, the railway that's 30, 50, 100 years old in certain cases. We want to be able to test our new train against that. And vice versa, we want to test the infrastructure to the same process, to allow the failure modes to come through, to understand them. So we were looking for somewhere for 20 odd years. We couldn't find anywhere, frankly, in the UK, because the UK is kind of a busy place. And we'd actually sort of given up looking here. I'd even tried to help the French build a test facility in the Pas de Calais near Valenciennes, but they couldn't do it either. They couldn't get planning permission. They had a cunning plan. They were going to build it next to the Belgian border, because then most of the noise and issues were going to go into Belgium. But even that failed. So it's taken a long time to do this. It's not easy. It's a very large facility. But the rolling stock facilities in Europe, Velim has got a 3-year waiting list to get in, if you're lucky. Wildenrath is largely a Siemens operation. You can get into it, but there are limitations to that. There are 1 or 2 other little facilities around, but fundamentally they test trains. So what do we do in the UK? We tend to, because I know running the acceptance panel, you know, the whole process of getting safety approval to test a new product on the West Coast main line, or somewhere, is actually quite difficult. We're risk averse for good reason. There is a good reason for that. We shouldn't risk our passengers on this. But on the other side, we need to innovate. We need to move forward. You need to see how other industries are doing that, and we need to move forward with it. So we'd spent a lot of time trying to find somewhere, and then somewhere along the way, lucky sort of things happened in that the Welsh government were closing a whole load of coal mines. And there was a coal mine that was closing, the Nant Helen coal mine, as it's called. Actually 200 years of coal mining there, the first deep mines, and then over the last 50, 60 years, they've been doing open cast mining. But they literally run out of planning consent. The line drawn on the map, they'd reached it. Even though the coal seam was 11 meters thick of anthracite at that moment, it was stopped, and there's no prospect of it being reopened around that. So what do you do with a site that's in a depressed area? It's closing the last 150. What do you do with it? So they've been looking, the Welsh government played with building a racing track and all sorts of things, a car race track in some parts, and they've been trying to get Aston Martin there and things like that. So so what do you do with this site? Well, it just happened that we sort of bumped into a chap from Welsh government, and from there we've grown into a site that could be used for this. And yeah, so that's the story. Where is it? Well, it's this wonderful red blob here. It's about 10 miles from Swansea, 8 or so from Neath. This branch line is the NAB, the Neath and Brecon Railway, as was. So it used to go over to Brecon. For the last 30, 40 years, since that railway was closed, it's been running coal mine, coal. The last coal train went out in 22, maybe 21 maybe now. So the line is in the sectional appendix is RA9/10, W6A, although I don't think a W6A train's gone in it in the last 30 years or so. But there's no structures on it to talk of. So actually we're quite confident that we can get anything pretty big up there. It's connected into the boroughs, and then you reverse back onto the Great Western Main Line. And so the site is up there. This green road here is the 465, the Heads of the Valley road. Is actually dual carriageway from Neath through to Gurneath, and then from Merthyr Tydfil to the Midlands, it's dual carriageway, and the last bit in the middle there is being done at the moment, huge bit of engineering, which will be open in 25. So actually this site is connected by dual carriageway to the Midlands, it's connected to the M4, and the haul road that goes up to the site has been running coal traffic, coal lorries for donkey's years, and is beautifully graded. They've even got 50-metre wind turbines up there, so there's no problem getting trains up there as well. So more pictures of it. It's kind of atmospheric, really. It's a large site on a hill. You've got the Swansea Valley going off down this way, the Delice Valley going down there, Swansea, Neath, etc. And it's basically the Brecon Beacons is here to the north of us. It's literally 85 metres across the boundary to the Brecons. Stunning view to the north. And we're going to build a railway in here. Sidings, campus, all sorts of things. On this as we go. So the site is 700 hectares of land. It's, say, a large hill. The last bit of the coal mine was this open cast pit here. It was actually 350 feet deeper than it is now. They filled in 350 feet of it, and it's still a stocking grey area. You could pick a very large number of football stadium in there on its own. I calculated the whole site. You can put 1,600 football pitches in if you want to measure things in that way. The idea being the outer loop, vehicle testing loop. I'll tell you more of the details of that. Infrastructure loop in the middle. Potential for all sorts of wind energy opportunities as well. The red here is 400 kV and 132 kV power cables, and the railway would actually run off down following the river down here past Seven Sisters and down to Neath. So that's the whole site, and actually there's a very large plan, not just to build the railway on here, but storage facilities and a whole base camp as well. It's not flat. And in fact, the first time I went up there, I'd gone up with a large number of Welsh Government officials. And we're standing on the top of the site and they're saying, well, it's a fantastic site to build a railway on. And I'm sort of going, oh, really? We're going to do this? But I've got converted since. It's absolutely stunning. When you stand here on this loop, and there's a 44-metre embankment along the top here and 22-metre cuttings here. So we're cutting a lot of material from here and creating this embankment here. You're standing on there. We will sell pictures for the scenery. I mean, you know, actually, you can sell pictures for the view. Right. Yeah, I've got to get it across here. Here we go. So just about here is this 44-metre embankment, and stunning view to the north. In fact, there's stunning views in all directions, to be honest with you. So I'll just move on. So the construction, I said 700 hectares. It's the same size as Gibraltar or Gatwick Airport or a whole number of places. I think you can put Hyde Park in it twice or something or other. So it's kind of big. We actually have planning permission. One of the biggest issues for getting a test facility in the UK is getting planning permission, the NIMBY process. You know, nobody wants to build something like this next to their backyard. But these people said, well, we've just lost all our jobs. And actually, we're not going to get any blasting anymore. So you're going to run a few trains around here, but there's no blasting and there's jobs. What's not to like about that? So actually, Powys and Port Talbot authorities have actually given us planning permission for a 24/7 railway. We can run it unlimited access. We've placed contracts. We've already run contracts for the outline design of the railway, the outline design of the energy system, and the sort of HQ facilities. We've run a full detailed contract for the earthworks, and we've actually placed the contract for the earthworks. We got to move 3 million cubic meters of soil, basically the cuttings, 25 meters deep, moving a lot of that soil to create the embankments. We are trying to do this with as much as we can serviceable material. So we're using the material on site. We're not importing large quantities of material. So we've spent a large quantity of time with geotech engineers, and I have a new version of this. So what's the collective for geotech engineers? Well, actually, I've decided it's a debating society. Lot of debate about, will this material that's pre-worked mine, will it actually consolidate? Will it actually sustain the railway? Will it hold water? Will it, you know, retain it? What's going to happen with that? Particularly with this embankment, where we're building an embankment on top of a slope of a reworked mine. So the question, and actually it's a kind of replica of what happened at Hook and the embankment that slipped there, in that there was an embankment built on the side of another embankment and it slipped away. So actually there's quite a few challenges in that, but that's an opportunity for innovation and research. We're going to embed in the original earthworks all the pore sensing processes, all the measurement of water, etc. And then we're going to add onto the new embankment all loads of sensing systems, so that we know if the assumption of the geotech engineer is the water will permeate through, but does it permeate through the new embankment and the old one, or does it stop? Because if it stops, you're going to create a slip pane and it's going to move. So we need to know that. We need to manage that site. This site is probably 10 miles from Aberfan. So actually, one of the sensitive things we've got to be very careful with the community is we've got to convince them that we know what we're doing. This isn't a slag heap, this is a designed process. But if you're the average person in the street, do you see the difference? No, it's just a pile of mud, isn't it? You know. So we have to get that right. But by using the serviceable materials, we're not importing large quantities of foreign material. We're minimizing our carbon footprint on that. And we're trying to do the same, by the way, with the railway. We're trying to get serviceable material from various places because we want to replicate a real railway. We don't want a brand new railway on part of this. Some of it will be new. Some of it needs to be a traditional 30-year-old railway. So it replicates the real world. But we do have the opportunity then of testing innovative products because we haven't got any passengers. We haven't got a timetable. This is a laboratory site. And I'll tell you about the safety case in a minute. So I'm going to try and run this video, if I can make it work. And I apologise straight away for my lawn. I'm very pleased because it's amazing how green it is. This is quality soil. give you some sort of scale of the grandeur of the site. It's really quite impressive. Quite interesting, actually. Stop this. The Atlantic. So wind load on the site pretty large. There is no wind barrier between here and the Atlantic. I'm just here straight up in Brecons, and if you've ever stood on the Brecons in winter, it's pretty windy. But it's pretty windy. But I'd say it's not flat. That's a reclaimed man-made hill. In fact, all these things are man-made. The miners see no problem. The hill that's just behind that one, it's 50 million cubic meters of soil. You know, it's a large amount of soil. So they said, well, moving 3 million, not a problem. That in a year, you know. So we'll kick on from that. So, right. So just a quick word on funding and timescales. So something like this is not cheap. We have 70 million from actually both governments, from the Welsh government and from the UK government, from BEIS actually. We have 20 million, and we have another grant, an innovation grant, that I'll talk about, another 10 million pound that's come in as well. But this is 70 million to help us build the place. We actually think it will cost us 400 million to build it. I mean, this is a non-trivial facility. We've got to move the earthworks, build the railway on top. I'll tell you all about the railway. We're going to put a business park on there and a hotel. I mean, there aren't too many hotels in this area because the Brecons are open in the summer, but very closed in winter. So the hoteliers will build a hotel, because actually what this site gives them is a base load all year round, and then summer is bonus for them. So hotel as well. So we're out, actually, we ran a public procurement process for funding, and we opened a formal process on the 19th of January. I can tell you that that has progressed well, and we continue to go down the process. And in fact, we will be formally inviting the lucky tenderers to bid in the very near future. So it actually looks quite promising that that will happen. Obviously, nothing's done until it's done, but actually it's looking promising that we can achieve that. We plan, say, we own the land from September last year. We've been working on the earthworks from late in the year, and actually the winter's not been too bad. We've managed to keep working, not all over it. And some parts of it have been just too bad, but other parts we've been able to work on. We're actually building the first phase of the sidings right now, which we hope to have open sort of later in the summer. We think we'll get the trace finished in 23, and we'll put the railway on it on 24, and we'll be fully operational mid-25. There's only one fly in the ointment, and that's the power people, but we'll come to that in a second. So that's what it is. That's where it is in Wales, and actually lots of public support from it in the Welsh government, lots of support in BEIS, and I'll take you through some of the positioning of that a bit later on. But let's talk about its capability. Let's talk about engineering, more fun bits here. So we're going to offer 3 types of facilities in essence as the railway system. So rolling stock testing, of course we'll do rolling stock testing. It's a loop, it can run endurance testing, it can run, and I'll tell you the details of that. But we can also do infrastructure testing on the inner loop. We can do storage maintenance as well. It's useful stuff because it keeps it's OPEX cost. It keeps the lights on, so it's useful from that perspective. You can do testing in that as well, quite frankly. The purpose of the site is to be able to test technology, test trains and infrastructure from cradle to grave. So brand new through to end of life, and all the bits to go with it. We're going to run it as a risk tolerant site, if I can describe it this way. So our safety case has started with the assumption that we're eliminating the human from the process as much as we physically can. So the inner loop, we intend to run it automatically, no human on it at all. So God forbid the train comes off. Yes, it creates a bit of a mess, but nobody got hurt. but that enables you to push the envelope. So now we can go onto the curve and look at the degradation curve. We can start sliding down that curve in a way you cannot do on a mainline railway. You can tolerate failure. You can tolerate the cracks growing because you want to know where they go. You want to know how fast they grow, and then how to manage that process to make sure that we don't have accidents, we don't have a catastrophic failure in some way. We intend to be the first net zero railway. We're connecting it to the renewables, and we do have to have that little problem solved, that how do you connect lumpy power that a railway is, pulling 8 megawatts and then breaking at 8 megawatts from a renewable system. They don't like that. So how do you sort that 24/7? And there isn't an infrastructure project like it. So a bit of a schematic diagram for you, really. Outer loop, big 7 kilometers, inner loop 4 kilometers. The outer loop capable maximum speed we've said is 177 kph or 110 miles per hour. We could run it up to 125, but we'd have to super elevate the curve if we're going to do that, this outer curve, to do that. The inner loop, 4 kilometers long, actually running at about 80 kph, but it's about duty. What we want to do is get lots and lots of cycles on it. We want to get lots of, so we don't want it too long because you don't get much duty on that, do you? So it's relatively short. It's all 25 kV, the sidings, you're connected by a link road that comes up here. So the branch line is up here, should be, this is the branch line down here, connecting up to the sidings area, maintenance facilities, etc. Link loop line that's actually going up quite a lot onto the loops here, and capabilities around that. So that's a very schematic process. Let's talk about it in more detail. So the railway system itself will be, so there'll be a full GSMR, independent GSMR on this system. So it's a standalone replica of the main line. The outer loop will be ETCS level 2, level 3, ATO. It's the full, what's called Class A European signalling system, the future system, as per the European TSIs. We actually have adopted all those into we transposed them all into UK law, and they're still UK law. It's the second largest bit of UK law that's got to be sorted out by the end of this year. I don't think the government's going to make it. They haven't made it on 1 or 2 other things, so we can't raise our expectations too high. They'll have to extend it. The inner loop will be traditional Network Rail Class B system, so AWS, TPWS, track circuits, axle counters, all the things that we know and love about the old railway, with an ETCS overlay. So it's classically East Coast Main Line, Thames Link, overlaid on top of the existing system. But it gives the footprint of a traditional Network Rail EMC process. The link road here is part of the outer loop, in that we're deliberately, this is the test facility. So the inner loop is actually got its own interlocking and its own RBC. The outer loop's got its own interlocking and its own RBC. The RBC then, the outer loop one does actually do the sidings as well. I mean, it's a gigantic overkill. There'll be another interlocking for the sidings area. I mean, one interlocking would do the lot, but then we'd be totally constrained. If we want to be able to test signalling, you want to be able to substitute without changing. So you could run the outer loop with the new systems, and you can play with and just substitute the interlocking on the inner loop, a bit like Network Rail did at INIF. You could plug it in and plug it out in 10 minutes. I don't think Network Rail ever realised that there was a plug in there. When you pulled it out, the whole of the East Coast went out. Interesting bit of safety case that anyway, we won't go there. There's an exchange process down here for exchange onto the Network Rail branch. We want that to be completely separate, so we're actually running it off renewables. We're actually running it completely isolated because we don't want it to affect our safety case. We don't want it to affect Network Rail safety case, so we can eliminate, because we're separated. Okay, and actually we get to there's about 30 miles of railway in here by the time you've got all the sidings in and the link roads in and everything else in there. We're going to put underbridge in there, so we can actually test an underbridge. Composite one would be nice. You can actually have one with a big crack in it. You know, I was always amazed in Pueblo. They had a steel bridge with a 2.5 metre crack that had gone through the base plate and was going up through the I-beam. And you're sort of looking at that going, well, if it was our railway, I'd just have to, you know, I'd be taking the tablets. But they had a brand new bridge there and they said, oh, no, it's really fascinating. The crack grows and it stops for a few weeks and then it grows again. And we're really, really interested to see how far it goes before it actually breaks, you know. Oh, can't do that on the main line. So we'll have that. We'll have a level crossing, a few overbridges. Actually, we've got a couple of those overbridges already there, composite ones as well. All sorts of opportunities in that because actually composite's plenty strong, but there's no standards for how you connect the beams to the deck and more importantly, the deck to the track. How are you going to do that? My guess is we'll really struggle with that. How will we keep it together before it, you know, because we know what happens in that sort of thing. It's like slab track and everything else. You know, you bust every component going until you work out how you get the elasticity in it to actually work it properly. So opportunity for all sorts of innovation in here along the way. Obviously, this whole slide deck's available to you. So sort of said all about the signalling, crossings, the telecoms, the standalone system, fully electrified 25 kV all round. So both loops. The whole system's 25 kV. We will have provision. We've actually bought ourselves a large static frequency converter, so we can do DC. We could actually do other frequencies as well. On the day that we want to do large access process going on there, and I'll talk about the net zero process in a minute. So there's a bit of repetition on these slides, but there was an element of how do we do this? How do we go into? So I want to talk about infrastructure testing and I want to cancel the word infrastructure anymore. And I now want to talk about through life engineering. My friend Andrew Starr is here and, you know, actually in other industries, oil and gas, aerospace, and it's a whole topic at Cranfield University, isn't it? Through life engineering is a formal process. We don't talk about that so much in the railway industry. We talk about asset management. We talk about, you know, and we have the regulatory settlements. In reality, that's a massive asset management plan. And so what we're planning to do is actually run a whole life, through life asset management system, a rolling stock system, a rolling stock testing system, and we have opportunities for system integration testing and to fully instrument and create a data center site. So let's talk about whole life engineering. So whole life engineering, how are we going to do this? Well, we're going to run a train around this 16 hours a day, 5 days a week. And we're going to run that with a 1,000-ton freight train with 30-ton axle loads. Why? Because I want to be nasty to the track. Because you've got to age things. You've got to accelerate the process here. Or we're going to run one or more of we bought three 360s already. So we've got 3 old Siemens D0 360s. They're nice trains. I know them well, the whole D0 fleet. So it gives us a nice wheel rail interface, aggressive. We'll load the train up. The idea of that is to put lots of cycles into the track, to punish the track, to try and get it to the point where we're putting 20 MGT, but actually because we're overloading it, we're over the standards. The EMGT will be quite a bit higher, 600,000 axle passes a year. As I say, we've got space to go up and down. The plan is to run it on 10-week cycles. So we run it for 10 weeks, continuously every day running the train. And then we stop for 2 weeks because you've got to have a possession time. You've got to have a time to take out a point or to put a new point in. This is infrastructure. Some of it, we sort of have split it into the intrusive testing, stuff that takes time to dig out a point, dig out a section of track, to the non-intrusive, which is a monitoring device that you can bolt on the side that doesn't actually stop things. It doesn't actually lock it down while you're doing that. But you need the cycle time to do this. So you do it 10 weeks, stop for 2 weeks, run for 10 weeks, do it for 10. And the idea of that is that you give yourself a process, you set up a loading process on the infrastructure. There's obviously space to do other things during the other shifts, and there's all sorts of opportunities to put another train on to provide that load. So you could actually run another train, a new train, to be providing the load. Bonus for us if they do that. And the idea is to accelerate the life of the site, push forward the asset degradation by automating the loop. As I said, there's no human in this. We'll allow cracks to grow. We'll be tolerant of failure because we want to explore that failure, whether it's on a new product or an old product. You want to understand those curves to full end of life. So let's just apply that. And it's just an example. So if we took HS1 built, some of it's open 15 years now, isn't it? It's got an asset life of 40 years. And basically, it's owned by a number of investors who dear Diane and co, has to promise that actually they have a plan that the asset life will be 40 years and they can start renewing it. And indeed, already the train operators are having to pay for the future renewal of that site. Now, if that assumption of 40 years was wrong by 5 years, so it's 35 years life, not 40, actually their financial plan is in the toilet. If it was 45 years, they've missed an opportunity, but they don't know. So if you took, let's say 200 meters, 2 string lengths of rail, and sleepers and ballast, you took that and put it into the GCRE site, what you can do is, and I'm cheating because I want to take pre-used, recycled stuff. I want to start it from the 15 years and accelerate it such that in 2 or 3 years' time, what my bit of HS2 looks like is actually 10 years ahead of the bit of HS2 out on the real railway. That gives up HS1, the opportunity of knowing what the failures are before they've got to them. They can see what their failure rates are. They can see the degradation. They can start learning to, how do I extend my asset life? What would I do to change my maintenance cycles to keep the thing working for longer? What do I do if actually there is going to be a failure of something before my 40 years? I now have a time to plan for that. And actually, HS1 is sort of saying, well, actually, this gives us much more credibility with our investors to do that. So actually, it's an example of how that might be done. Network Rail is talking about using the site to do its R&D and its asset management, its regulatory process. Potentially HS2, Transport for Wales, Transport for London. Lots of people, even Irish Railways, are talking to us about the possibility of using the site to put sections of their railway on and actually use it to test future development. We've got quite a few infrastructure suppliers interested in doing so as well. British Steel are saying, well, we're developing new steels. Could we actually try some new rail on the site? It took me 5 years to do that in Network Rail to get to putting IMechE rail and things like that, and actually proving it to the satisfaction of the railway. You know, we had to do it properly. Platter and Toya spend actually an awful lot of time in Pueblo, developing new strategies all the time. They're trying to develop a better way of managing ballast life, etc. They're long-term tests. They take a long time to do, but they're telling you in advance of what happens on the real railway. So what you'd do is you'd have sections of the rail set up to look like a piece of traditional Class B signalling system on here as well. And what we're doing is we're running a train round and continuously loading it up. So we've got all the opportunities of playing with lubrication, with rolling contact fatigue, with all the wheel rail interface issues, all the things that we all know and love, bogie performance, curving, you know, the fun and games we can have. You can run it either way. There's a station, platforms in the middle in this Delta Junction area. There'll be platforms as well. And in fact, there's a few virtual station stops around there. So you could actually force the train to stop and start all the way around it if you wanted to as well. You can do that with the outer loop. If we move on to the outer loop, you should say, doing that, say longer, it's a full ETCS level 2 system, 110 miles per hour, potentially to go faster. The interesting thing is the link road is 1 in 50 going 1 in 37 at the top. So it's as steep as Licky at the top. So actually the opportunity for testing a train on hold and start and stop, all the fun. I was thinking, Graham, all the fun and games of starting a train and rolling back a train and then starting it, blowing out all the breakers. It was great fun, wasn't it, when we were in control years ago? And used to shut down Hamburg Metro, didn't we? Doing that somewhere along the way. Anyway, so again, actually what the science of this is it's a bit like going back to school. When you do a science experiment, the first thing you get told when you're in the science lab with the teacher is you have to have your controls. You have controls which you keep constant and you vary a part of the system. If you vary everything, it's chaos. You have no idea. So essentially the vehicle testing loop has got a constant infrastructure standard. It's largely accredited as a full 200 kph tier-side compliant Cat 1A network railway. And you vary the train. You play with the trains. A nice new train on it. It could be a modified train. You can do that. The infrastructure loop, exactly the opposite. Constant train on it, vary the infrastructure and play with the infrastructure. Sidings, lots of sidings, lots of reception roads, maintenance shed, kind of important because when you're doing this testing, you're bound to break something. Lots of maintenance facilities, refueling facilities for not just for diesel, but for hydrogen, for biomethane perhaps, batteries certainly, recharging. So lots of that capability, and the HQ sort of building is in the middle here with the link roads going off sort of away this way. Always amuses me, Wembley Avenue. The Welsh didn't appreciate my sense of humour on that. Of course, you can do railway system integration testing here now. So look at this as an inverted figure of 8. You can go from the outer road, which is brand new Class 1, Class A railway, to the inner road, which is Class B. And what you're doing is you're doing a transition, not just from level 2 to level 0 to level 2 in an ETCS, but you're doing a transition from interlocking to interlocking, from RBC to RBC. It's actually a quite nasty, it's the worst, nastiest type of transition that the railway sees. It sort of replicates something called Crossrail West and East. It could replicate something called HS2 to Crewe as well, 5 years before they can do it at Crewe. And what you can do is all the EMC problems, all the latency issues of the radio system, the interlocking systems all talking to each other just at the worst moment when it's transitioning. If you can make it work there, you'll make it work on the main line. If they'd had that before Crossrail, they could have done that and solved themselves kind of a lot of trouble, which actually they're still struggling with. So you replicate the real railway, and of course you've got EMC signatures of the new and the old on that. So how are we going to control all this sort of thing? Is, you know, the lunatics are in control of the asylum, or the engineers are in control of the asylum. I like to think I'm the engineer, not the lunatic, but maybe some people think different. So we're going to use, we've started down the road of using digital twins for this. So we want to use the digital twin because you could say, why are you building this facility? We've got all these models now. We've got all these wonderful computer models. What do we need all this? There are certain universities that would tell you that as well. But if you go to aerospace, if you go to automotive, they will tell you they need both. Because if your model is not representative of the real world, if it's not properly calibrated, it's rubbish. It's rubbish in, rubbish out. You have to validate between the two. They use the modeling to accelerate their testing once they you know, can validate the models, but it allows them to take another step faster than they could take the step before. So actually this is about accelerating that process. So it's all about building the data, managing the process to integrate with research and confirm the results with the modeling process. And there's a whole relationship of data, collecting the data first, building that into an environment, a BIM environment, building that into the real world process of linking that to the real world with the BIM processes that you're designing to. You then put the sensors in, you start enabling a connection of that system with the research processes or the new equipment that you're testing. And ultimately, you can then start getting through and underpinning that data with modeling processes and creating simulations, etc. We started doing that. We've actually created a 3D model of this site already. I might try and run the video if you can remember how to run it. So this is a 3D immersive video of the site. I put it in really to show you that the site isn't flat. I think I might have mentioned this. That's a 44-metre embankment over there. This is the sort of eastern end where the sidings will be down here. You can see the cuttings in the middle there where the train, and you can see this link road which lunatically goes up onto the loops with these two big hills in the middle here and the railway running around the outside of it. That's the Delice Valley. That's where the railway, the NAB goes down now. And you can see this is the old coal mine, or what was left of it. It's basically the whole site was mined. So they've gone east to west across the whole site. That was the last end of it. And of course, this is the Brecon Beacons. All this lot here is actually now going up the Brecon Beacons and beyond. And that's the 44-metre embankment just on that top corner there. So we've started down this road. We've created a whole BIM environment for the place. We're actually using that to simulate. So you can simulate a station, simulate a depot, you can build that data into those sort of processes. We can link it to create the hardware in the loop. So this is Harold, the pantograph rig at Huddersfield. It runs a simulated process for the wire. So you're testing your pantograph, there's a computer putting the simulation movement in for the wire. Well, you can substitute that, you put the real wire in and create a hardware in the loop process for that. We can start imagining the real world and start looking at all sorts of things from slope to composite overhead line systems. How far could we move the stanchions out? Actually, it's about wire stability. That's where Great Western went wrong. They kind of put too many stanchions in to try and keep the wire in. Nuts. Never let electrical engineers play with mechanical stuff. And obviously verification, the whole question now of software verification of signalling systems. Well, we can do it here. We can even put faults in and have a look at that. And you obviously moving into multiple cycles of the product and working it through to end of life. So we've done all our contracts with BIM2 to start with. We've started down the 3D modeling road. We're actually migrating our BIM data into a sort of full digital twin as we speak on this, and we want to put a whole digital background around the site to connect all the test systems in, all the new, whatever we're doing is connected in, and we can run research processes, we can control the process as well. So it's very much that sort of journey that we're trying to build a place that controls it. It's not just about data, it's purpose, operation control, safety, but then innovation, research, and whole asset management. Skills and innovation. So many of our new systems need our people to be trained. And actually, you have to know the failure mode processes. You have to have the maintenance and operations manual. When you buy your fridge, you do actually get something like that. And your car, how good they are, depends on how well the manufacturer's worked on that. How good are we in the railway at that? How good are we? A number of times I've heard network rail engineers saying, well, there's a new bit of kit down there with no idea what it does and it's broken. When do you think it's going to get fixed? No idea. So linking this with skills and innovation, linking it with the universities. We've already run one innovation competition. which was actually about stuff to build the railway. So we're embedding into his flywheel technology, storage systems, composite materials of overhead line systems and bridge systems. There's I think there's 20 so far in the process. They're feasibility studies. 3 or 4 of those will get embedded into this. We'll put them in the build. We'll put them in. Because why would you build a brand new thing and say, oh, we want to modify it to put something in? Let's build it in from day one. And we've been running a competition to actually say to suppliers, well, you know, you want to put something in, you can put it in here. If you give it to us, we'll put it in for free. So there's a handshake, you can demonstrate it, certify it. The whole purpose is getting to certification and verification of the product. So you can do that here too. And of course you can train your people. So there's a whole load of benefits, dealing with the whole gap here for not just the UK railway, but actually for European railways. And we've got a lot of European railways, and not just the usual partners, but the large red one in Germany and the various others actually saying we kind of like coming to you as well. We'd be very happy to take their euros. They'll have to transfer it into pounds first, but we want them to do that. And we are actually getting a lot of support from government, I have to say, in really good. Welsh government, absolutely fantastic, supportive of this, because this is jobs. This isn't a railway for them. This is social economic development in the area. The opportunity to grow industry, to grow actually a new sort of business, because coal mining is gone, sort of thing. You know. And being able to test at high level TRL, really important. Nobody can do that. And we want it to be a magnet to bring in other things, because that strengthens our business case. And it's not just a testing site for railway. It's a testing site for spectrum, because actually we can, there's no real sort of, there's no other user in the area. We can have all sorts of capability in there. We can do FRMCS. We can do European FRMCS and UK FRMCS. They're going to be different, by the way, because there's different spectrum issues in the UK. Gravity is different in the UK. You need to understand that. I think that's the reason of Brexit, isn't it? But anyway, we're going to put lots of trees on there, say a hotel, and we're going to do the energy renewal bit and that. And we have a nice campus, 100-bed hotel, nice control room, and actually down here in this bit, just down there, you can't see it here. There's wild water swimming and various other things down here. I'm not sure who's volunteering to do that. It's not me. But actually, it should be a nice place to work. So we're building a sort of place in the middle of the place. It's literally in the middle. Railways below it. HQ's in the middle level. That's the reception area. Hotel above. And possibility of if you've been to Myra, Silverstone, all those sort of things, all the research facilities that they have as satellites around there. Why can't railways have that as well? We could do that here. I mean, it's sort of starting to happen in the Midlands as well. But, you know, we need to do more. We need to create that innovation process. And lastly, just quickly, energy. So I said on the slide earlier, there's 400 kV and 132 kV above the site. Can you get hold of that? Not easily. The government doesn't know this because the government doesn't have a plan for it, but we're all going to be net zero in a few years' time. But the grid is busy saying no connections. You can't have a connection, a renewable connection. If you want a connection, give us 35 million quid for a deposit, and we'll give you a connection in 2033 or something even later, 36 sometimes. They've actually banning all connections. It's crazy. I don't know how that fits with government policy, but anyway, that's how it is. We are dead lucky. There's a 26 megawatt wind farm next door. So we can have a private wire straight into it. And we bought ourselves, say, a large SFC, which we're going to connect the two things together. And we can now, with a little bit of other engineering, probably a storage system as well, we can connect the lumpy stuff of the railway to the smooth stuff called the wind turbines, etc., and make it work. We can electrolysize and create hydrogen on the site. We can do all sorts of other things with that as well. But we've got to do it, frankly, because we won't get a grid connection, although we do, because of course the wind farm already has a grid connection. So we connect to them and then we go through the back door to the grid. It's a bit of security, but actually we'll probably have our own wind farm and solar on site. I said 10 to 15 megawatts of solar. Actually, we can probably put 80 megawatts of solar on site. It's massive. And it's probably the energy companies that are going to be quite interested in this facility as well. It's not just the railway, it's the energy. And there's a massive opportunity in this. So, you know, we've got all the bits from hydrogen to batteries to solar to everything on the site. The site's so big you can separate them all out. But the railway's got a massive opportunity here, and I don't think they really understand it. We're the only people outside the grid that can distribute power. Nobody else can. The large industrial sites use a lot of power, but it's only on that site. Can they move the power to another site? No, they can't. We can. We do. In the southeast, we've got our own distribution system on the DC, and actually the 25 kV can move it quite well as well. So actually, if we're clever, we can store our own energy. Why would we sell it back to the grid? If we buy energy at X kilowatt, XP per minute, you know, I don't know whether it's 30p a kilowatt hour or whatever that they're buying the grid from. What do they sell it to the grid at? You have to get a really clever train that's got clean filters on it. You've got to have the right regeneration system in the power system. Bloody expensive to do all that. Why do you give it back to them? Why don't we have our own storage? Just store it ourselves. We're really good at that. Store it ourselves and then reuse it ourselves, because actually that's what our trains are capable of, because we're essentially electric. So why would we give it back to them? So the business case for doing that, one, but two, we can distribute that power. So if you connect the Brighton line to the Shoreham wind farm and run a 150 megawatt storage, you can run the Brighton line all day on it, and it regenerates itself, you know, restore it. And guess what? You can reverse run it into the stations and put the EV charging points in, and they'll pay us for the money, not the grid. Lots of money in that. We're going to do that first because we can. So we're trying to solve those issues of connecting, because there are some issues of connecting lumpy stuffs with Rio, with Regen, and we can demonstrate the system and we can sort of certify the system, because that's the whole purpose of the site. So that's the end of the presentation. Just trying to catch Noel out by pretending I wasn't going anywhere. That's a quick run through. I've bombarded you with a huge amount of data. You won't remember any of it. Well, hopefully you'll remember some of it. But I hope you've found it interesting. We are going to do this. The lunatics in the asylum are convinced they're going to do it, and nobody's going to tell them different. So we're just doing it. So thank you.
Well, so we'll open the floor to. We can open the floor to questions. If you are going to ask a question, please do the normal thing. Raise your hand. There is a microphone that's going around. You need to speak in the microphone, otherwise our colleagues at home will not be able to hear you. So please, first question.
Thanks. Andrew Starr from Cranfield University. So Andy, my question is about the way that you interface physical testing with your digital twin. There's an idea that a digital twin could completely replace physical testing. Well, that's clearly not your agenda, no. But physical testing remains quite an expensive and time-consuming thing to do. So where do you think the balance is?
Well, actually, we're all on a journey here. We don't know the answer to that, because actually there is no standard for a digital twin. It's a journey that we're all going down. We don't actually have a roadmap for it that's pre-designed by people who've done it before. We're working that through for ourselves. And it is absolutely true that we've got to work in harmony. The word digital twin, the word twin is kind of important here. It means two. It means a physical one and a virtual one. And actually it's the marrying of the two. It's the efficient use of the two systems that creates value. I mean, I don't know whether you've seen anybody who watches Formula One just recently. They have a new car for this year, and one or two of the manufacturers of the cars have done rather well out of it. and 1 or 2 have done rather badly. Yet they did all their modelling, they did all their computer modelling, and they were all convinced they had a good car, and didn't quite work like that when they put it on the track, because they didn't necessarily get a true representation in the digital twin of the real world. Now the reality is our real world is a train chunking along at 125 miles per hour, or maybe it's a freight train travelling at sort of 50 miles per hour. Actually, you look at the dynamic motion in that, replicating that, and how the wheel-rail interface is working is really something of great wonder. I mean, it's a connection point this big between the train and the track, and it's rather wonderful in that it does really do a very efficient green job. It's interesting because it's our best, you know, the coefficient of friction is so low that actually we get good energy efficiency, and it's our greatest benefit. It's also our greatest disbenefit because we can't stop the train on it. So, you know, so it's our great benefit and disbenefit at the same time. But actually understanding that science is something that if a railway doesn't understand it, it goes horribly wrong pretty quick. And we've discovered that in the UK more than once. And many other railways have discovered that more than once.
So if any of our
Right.
Thank you.
Sorry, Andy. If any of our online guests have got questions, please type them in the chat. There's another one in the room, another 2 in the room.
Hi, Andy. Chris Gibb. Can you tell me why I would come and store my temporarily disused trains at the site?
Because for one reason, you might struggle to find somewhere else to put them, because there is storage, but not necessarily in the place you want it. 1, 2, actually you might want warm storage. That's harder to get in the UK. There's only a limited amount of it. 3, actually it's a site that's secure. You might want to also be modifying the trains at the same time. So you might want to be saying, well, actually I'm going to store but modify my train for a new lease in 2 years' time, but I need to change the functionality of the train. You have the capability of doing it here. You may not have that in too many places in the UK. So it's things like that. It's not necessarily, it's a competing business. We're not trying to say that's unique. We're saying it's something that we know there's a shortage of, and therefore we can sell it, and it has opportunity.
Thank you. Back.
Malcolm Dobell. Andy, excellent presentation. Thank you so much. But the thing that interested me was the OLE and the possibility, and then you expressed interest in the Germans expressing interest in coming to the UK. I'm thinking that the height difference between OLE in Germany is a bit different to how it is here. And will you have adjustable height OLE?
Yes, we will, because we're building the outer loop, because I've omitted to say this, we're building the outer loop as European gauged. So it's actually gauged for GB ABC, as it's called. Hilarious called GB, isn't it? But the European gauges, the outer loop is gauged for European gauge, which means that the wire's got to be high enough for that, but at the same time, it's also got to be appropriately low enough for the UK process. So we are going to have some adaptability in that for that. But why do we design an overhead line system where we spend a fortune trying to develop the pantograph and the characteristics of the pantograph, and our basic process of the other end of the spring, called the wire, our only control of it is to tension it. That's all we do. We try and, it's got to go tight, hasn't it, to stop it from wobbling around. We can't run 2 pantographs because it's all wire, you know. Actually, there's people playing with dampers, but if you put dampers on every stanchion, you can't afford it. That would be ridiculous. But if you can put a damper on every 10th stanchion, you're starting to look at a sensible process. But you can only do that as an integrated system design. You have to have a mechanical characteristic of the wire and the dampers to reflect and work with the pantograph. And then you could potentially run 2 pantographs together, because you wouldn't have a standing wave on the wire. You obviously design that out in that process. You have to let a mechanical engineer do that design. But unfortunately, it's controlled by the electrical engineers. Apologies, I'm an electrical engineer, but apologies for that. But the reality is they do have to let the mechanicals do it. So we're going to have carbon fibre in there. We're going to have dampers on there. We're going to look at how you put those stanchions in. Why do you imagine the damper is a separate device? Why can't it be the arm? Why couldn't it be part of that process? Why don't we be clever about integrating those things in there? Because actually it's reducing the number of components in there. So the insulator could be the damper, or it could be the whole arm is a damper in certain circumstances. But we wouldn't know how to even start with that without this sort of facility.
We have had a number of online questions, so I'm sorry, I will take one of them. We have actually only got time for a couple of last questions, so I'll choose one at random. If budget was not an option, would you do anything differently, or have you achieved everything that you could possibly think of?
Well, we've been the kiddies in the sweet shop, and we've been going around saying we want one of those, and we want, oh, that's a nice red one, we'll have one of those as well. So we've been trying to buy everything we can, but then, of course, the accountants get on as, oh, that's going to cost a bit of money. So we've tried to provision it for providing all the facilities we believe, and certainly talking to our potential clients, whether they be rolling stock or infrastructure, we try to sort of provision as much as we can for the base of the process. And we've allowed for the possibility to build a double track on the inner road or the outer road, so the trace is wide enough for both. We've allowed for different power supplies. We've allowed for all sort of every potential in there. We've tried to allow for it. We can't buy every single thing, but we've got a core which we think is enough to create a really interesting, unique facility. We have opportunity to add all sorts of other things on as we go, and yes, we will buy more sweeties as we can afford them.
And one final question from online: has there been any consideration of multi-mode testing, such as battery electric buses, leveraging the grid connections and light rail?
Yep, we've looked at many of those options. We've been talking to the Highways Agency, because the Highways Agency said we'd really like to have a mile of 8-lane motorway with 2 ramps at either end and an A road down the side, because we'd really love that to play with that sort of thing. Because at the moment they've got a bit of runway at Melton Mowbray or somewhere, the Cotswolds. But it's literally a bit of old runway. It's not a motorway. So they said, well, could you put that in? And we sort of looked at it and said, yeah, it's just drop in the middle. It really would just drop in the middle. And they said, do you want it curved or straight? And I said, well, actually, curve would be good. I said, well, that would be better for us because we can curve it around the hill. But, and actually, if you think about it, the OPEX costs of running such a facility for the National Highway, same as the OPEX costs of running the railway, the massive opportunity for saving. So we've looked at that. We're looking at the level crossing type interactions as well. There's a massive opportunity. Do you think an automated car recognises a level crossing? You want to see some papers done by the SNCF group that were at the WCRR last year. Automated cars and non-barriered level crossings are a particular interesting feature. Didn't go well, shall we say. So is there opportunity in that? Is there opportunity with light rail, heavy rail interfaces, the whole question of slab track? And, actually when you put a slab track into a tramway or something like that, the enemy of the track in the tramway is the lorry, is the bus, because it's running on that. And actually you just watch it, it just wears out that bit of all the crazy paving around it. It's all ruined, isn't it? And poor old railway sitting up here, and actually, so actually that sort of integration is what we need to do, because we need to be able to work out how you change that cost base, because it's just too expensive, isn't it? But again, here you have a facility where you can test at your leisure in safety, and you're not worried about failure, because you haven't got to worry about running Monday morning, because who cares? Well, we do. We like to run it, but we like to find the failures.
Thank you, Andy. Can we have a microphone up the front for Matt, who I'd like to invite to give a vote of thanks?
Thanks, Noel. Andy, thank you for fascinating lecture and really a huge interest into the topic of GCRE. what will effectively be a massive railway laboratory. Now, I think the phrase world-class is very much overused in the UK, but this is a genuine example, I think, of something that will be world-class and certainly be a most important addition to train testing capability and plug a huge gap in that testing and innovation infrastructure. But also allowing really a jump into the 21st century as well, with both digital twins and software verification as well, an area which is clearly of huge interest as we move forward. Now, the lecture was titled Thinking Differently, and perhaps the most obvious area of thinking differently is in ambition. What a huge ambition this project has. But some specific examples, I think, are about eliminating the human, that's thinking differently. In terms of signalling, gigantic overkill, I think, is the phrase you used in terms of signalling capability. That's certainly thinking differently. And also tolerating failure and thinking differently, that's one thing, particularly if you're on, well, you won't be because it won't be any humans, but a failure on top of that 44-metre embankment. So tolerating failure is something which clearly you need to eliminate the humans from that. Some massive numbers with the project. 3 million cubic meters of soil sounds an awful lot to me. 700 acres and 30 miles of track. I mean, this is a big, big project. Also with its own its own hotel. So if you fancy taking your holidays in the summer here, that's going to be open to you. And clearly, it's not just about rail. I think that was a point that Andy made. The capability here to do all sorts of different testing. So I'd like to thank Andy, and I think you've probably got the most interesting job in rail in the UK developing this. But thanks so much for a fascinating lecture, Andy, and I'd like to thank him in the traditional way with a round of applause.
So on behalf of the Institution of Mechanical Engineers, the Railway Division, and indeed the Railway Engineers Forum, I'd like to also add my thanks to Andy for what has been an incredibly enlightening talk. We've all known about GCRE, it's well publicised, but actually it's rare that we get to hear that level of detail. And as engineers, I think we can all see the possibilities that stretch beyond us. So on behalf of everyone here, on behalf of the 85 online participants that we had tonight as well, once again, thanks for your time today. Andy has to disappear because he's presenting at the RIA Innovation Conference in Nottingham tomorrow. So he's a busy man. He's getting him to come and speak to us. We're actually honoured that you've taken the time out of your busy diary to come and do that. So once again, thank you very much. That concludes our presentation for tonight. Thank you to all the online participants. They've all stayed online throughout, so that shows you how interesting. That's very unusual. And thanks it's great to see so many people here. So good to see you all. I wish you all a safe journey home. Thank you.